Okay, well, I'm using my tripod, but I'm using it up on a shelf, laying on its side, with the legs out and books on top of it. So it's sort of a cantilevered clamp holding my camera about 3 feet, maybe. I don't know, what is this? This is 2 feet up from the tabletop. I'm showing you out to the edge of my table here and just about the edge of my workspace there. And I'm going to the edge of my quad pad. I call it quad pad. It's a quarter of an inch per inch quad, right? Um, this is how I grew up doing my engineering, was on quad pad. So there it is. We're going to talk about wiring all-wheel pickups, okay? Um, don't need a comparison, I don't think. I mean, I have something maybe I could show you something like that. Oh, I do have a comparison. I had this comparison right here. Forgot. Ha! That's what I had it for. This is a northern tender that was sent in for updates. Okay, they want it worked on, and what you'll see is a big brass strip down the middle, brass wheel here, brass wheel here, brass wheel here, brass wheel here, and it has an auxiliary pickup back here. Maybe something inside, not sure. I haven't opened it up yet. But in any case, power comes from the track. You know that story. One side of the track has base, and the other side has the variable power coming in, and the wheels pick it up, and there's a wire on top of this rivet inside, and it goes up inside the reverse mechanism. Wire here on top of that rivet goes up inside. So these wheels pick up one side of the track, these wheels pick up the other side. These wheels are plastic and they do nothing. I mean, they roll and they support the balance, but they don't pick up any power. So what I always wanted, and I've liked it, was what I call all-wheel pickup, where every wheel is metal. In this case, they're brass. Every wheel has a little tap off of it to a wire, and that wire goes up inside to a controller, and that allows every wheel to then be a contributor to the power pickup. So every wheel rolls on the track, every wheel gets power, every wheel has a little wire coming off it. Instead of a brass lead, we have a piece of wire, and that wire is soldered to another wire, and then that wire comes out to a what I call power distribution board in our case for the next gen stuff, but it comes up and goes into the controls of the engine. So what we're going to be talking about right now is the mechanisms that we've already built and the components that make up the wire pickup. How are they made, why are they made, what they do, okay? That's what we're going to talk about. I'm going to get something out of the way right now is the type of wire that I use, and I'm going to try to make sure yeah, that's right. I think that's right side up. I'll make sure it's right side up, but that is from Dependable Spring Company, and they sell on eBay. It's okay. They're very reputable, great guy. Owner's name is George Latira. They're I think they're out of Washington State. No, Oregon, Sherwood, Oregon. They're wire and spring company. And this wire is a 0.016 inches, and you get 15 feet at a time, and it's about $16 plus shipping. And it's beryllium copper spring wire. And you got to be careful. You don't want to get a cut with it or anything, but it's okay. It's coated with silver, and it's extremely conductive. It's a very good conductor in that regard. And what I'm going to show you is what we do and how we do it. Now the requirements for the pickup would be, I'm going to use my black pen because I saw that work out real well. The requirements for the pickup are, get this kind of out of the way and start with this. You have a wheel, and you have another wheel, and then you have your piece behind it that is our truck that the wheels go to, and there's a little screw there that has where you attach the. Are you seeing this? Yeah, good. Attach this thing. So in order for this to fit on here, the spring that we build has to be a certain length. It has to have a loop in it, and it has to go out like that, so that we can put a screw down that thing, screw it down here, and the spring needs to come up to the axle a little bit. Okay, so it's going to go like this, so it's going to look like this, go up, and you got to know that distance, you have to know this distance, and you have to know how much wire is required in there so that you know how much wire to cut. So I've done this chart for you, and I can explain that. The four-wheel truck centers are further away than the six-wheel truck centers, because with six wheels, if they were the same, they would get too fat. Okay, so here's the six wheels, and that's the center. This is the four wheel, and that's their center. So as you can see, you need a shorter piece of wire to do this than you do to do this. That's the way it works. So for the short wire, you need to cut it at 48 millimeters, okay? And you're going to use 12 millimeters to make that loop, and that gets you down to 36, which is exactly what we need to go from this inner hub to this inner hub of the wheel, so you have good contact, a little bit of a spring, and you're bolted down to the pivot frame, okay? That's for the four. Now for the six, we're going to need a little shorter, so it's going to be cut. I did it backwards. That's for the six. I'm so sorry. So this is for the four. Ha! So you're going to be, oh, see, you can't do that. This has to be the four. This has to be the six. Oh boy, I really screwed up, guys. Good God. I have my little chart here, and I'm bringing it over, and I did it wrong. I flipped it. I had the four here, and the six here, and the six here, and the four there, and I'm referring to this pencil mark you can't read. Okay, start over. The four-wheel truck needs to be cut at 58. And you're going to lose 12 for that, so you end up with 46 inches. And that's the distance from the inside of the wheel to this side. It's 46. Okay. Now for the six wheels, see, I just did it again. I flipped over in my brain. The six wheel's closer, so you need a shorter wire. So you're going to cut that at 48. So it's going to be 10 millimeters shorter. And that's going to leave you with about 37 between the wheels. So you can have a wheel here and a wheel here, and it's going to be just a little shorter as it comes in. Okay. Sorry about that. I hope, God, I'm so sorry about it. I hope that works. Keep it straight. Refer back to, maybe I'll make a chart and send it out. In any case, the four wheel's longer than the six wheel by design of the side frame. Now, this is the pivot piece here, and I put some wire on here so you can see what the differences were. It's just a littlest bit, but it counts, okay? When you're making yours, you have to make sure that it comes in under the axle, and it has a little spring, and how much suspension you have, you could actually lift the shaft up off the wire if your suspension has too much motion to it. So you may have to pull these up or give them a little bend so that they come up under and touch. The other good advantage to that is this actually acts as a spring, so it gives you a little bit of a suspension to keep that wheel down onto the track. Okay. Oh boy, I feel terrible about that. So you pull this wire out, and what I do is I'll mark it. I like pencil, but I also use this black thing. So I'll pull it out and I'll mark it where I want to cut it, okay? And then I get my cutters. In this case, I was using my needle nose, and I would hold it at the end, and I make sure I'm flush with the mark, and then I cut it, and make sure you hang on to your wire because it can fly a little bit. So you cut the wire and you set it down, you verify you got what you want. Now, the other thing that I want to do is mark the center of the wire so that I'm going to form that, and I want to make sure I'm clamping it on the center, okay? Now for wire forming, there's a jeweler's tool that's just tapered pliers like, and what I've done is I've marked it. You want about a 2.5 inch, 2.5 diameter, 2.5 millimeter diameter of a hole for our mounting screw. And the mounting screw is a number 2 screw, which has a 2.3 diameter. Then what we want to do is you hold it with the radius looking at you. You clamp it wherever your spot is. Make sure you've got it semi in the middle, okay? And then with that radius, you're going to bend it, and you're going to keep it straight, and you're going to bend it exactly as you can, the best you can, around that piece. Then you're going to bend the other one as best as you can around that piece, so that you end up with 2 pieces sort of like that. This is not a very good bend. You guys made me nervous, okay? This is not a great bend. I would probably not do this, or I'd try to tighten it up. You want it to be tighter against the anvil of the tool, if you call it that. Let's see what I can do with that, just to prove my point. That's a little better, but it's not great. Okay. Then you can put your screw in. Then the screw has a 3 mil head, so it's not going to stick out. See, it's sticking out a little bit. It's not bad, but it's not great. And then you would screw that down into the pivot train, and it would go under the axle. Now put 2 on here already. You can see that. And there's the pivot, there's the angle, and you can see how much this has. And if I hold the other one up here, you can see the 2 wheel is longer, but it works. I've mangled this a little bit. So it would go like that. So you'd fit them in there, screw them in, and the end result is you have the wires under the truck, and they roll, and they're free to roll. They don't bind. Typically they don't bind. I always like to show off my wheels. There we go. So they're spinning as I flick them. They spin really well. Okay. So that would give you all-wheel pickup once that's the wires inserted. However, you do need to pull the power off of the wire. So what I have been doing is on the back side. This piece always goes to the outside, and you're either going to put a coupler or a link connector in there. I don't mean link, a connector to the drawbar. So I usually tap into here. This wire is easy to solder to, so you put a little dot of solder, you sort of like pre-solder, then you hold your wire up underneath and you just solder it right to that, and then you'll thread them up through the chassis like I show you here. And in the newer chassis, let me show you that. That's a good point. In the newer design of this thing I show you here, you'll see I have a box, and all that box is doing is hiding this machination. But it also, see how these sort of hang down? It holds them up so they're flush. Oh, and here you can see the difference in the wheel settings. You see that? The difference? So the wire on these are shorter than the wire in these. That works out. This shows you better, doesn't it? I didn't even think of doing that. But at any rate, there's the difference. Now in the 6-wheel, I'm only doing these 2 wheels for now. I have a plan to get to the other wheels, but we're getting 8 wheels on both sides. I still call it all wheel because you're still getting a lot of pickup on that. And so you route the wire up through. Now that's all on the plastic stuff you may or may not have. If you have a vintage machine, right, plate, and you wanted to put all-wheel pickup on it, 4-wheel pickups or whatever, well, 4 for the smaller engines, right? We have this device. I have them in different heights for the thick chassis of 3D printed. They're thicker. For the thin ones, I use metal, so that these are shorter, like they're like 4.5 millimeters. You put it's not much of an insulator as it is just a piece that will pivot around, okay? Then you put your piece on, your truck on. This is on there. It goes like that, and you get your shoulder screw, and you screw that in, and you can have all-wheel pickup on the metal chassis. It bolts right on. And I have built several of those as well. They don't last because I start putting electronics on here, and as soon as I do that, I have to introduce some plastic for insulation. And once I get one piece of plastic on here, it just takes off. Next thing you know, I've got a full chassis in plastic, and I'm done. I have the holes in it and everything, and it's much tighter. But you can do the metal chassis. You can update one of your older engines, put in all-wheel pickup. You wire it, you form the wire, screw it in, solder it up, run it up. The wire I'm using is 22 gauge flex shielding. I get it from the train tender, and get it in a roll. I forget how many feet, and it does a great job of being flexible and maintaining continuity. It's a thin braided wire, or wound, so it won't break, and it has a lot of flexibility built into it. So that's what we're going to be doing for this guy. I'm going to take, I lost it now. It was there. Now it's gone. My little show and tell piece of wire. At any rate, I'm going to take the shorter piece of wire. I'm going to build a couple of more and put them on this, and build that up for Leon. I told him I'd build him one truck, and then the other one he can build. Oh, on these inserts, just if you're not familiar with them, this is a brass insert. You could buy it. I sent the link up, I think. I have this. They're either on eBay or Amazon. It's a 4x40 threaded brass insert, okay? And it's knurled on the outside. This is a 440 shoulder head screw from American Flyer. So that works beautifully. And the two ways you can put these into the part, you fabricate the hole just undersized, so it's like a press fit, so that if you want, you can put it in a vise and press it in for a press fit. But what I like to do, I don't know why, but I just feel better about it, is I take the tip of my soldering iron, and I just hold it in here until it starts to sink, and there's a little bit left, and then I go over to a piece of wooded surface, and I press it so that it's flush with the top, and it's sunk all the way. And that's exactly how I did this one. So you can see this one is flush to the top, and it will hold. It's molded in, you might say. The melted plastic goes around the knurled part and holds it in. Can't get it out. Okay, really strong. And they're not expensive. Pricing. I have pricing on my worksheet that I just loaded up to the 6-wheel tender on Thingiverse. The whole bill of material loaded up for you guys, so you know what's needed, how much, how many, and where you can get them. And that's on the Thingiverse as a download. I think it's a Excel file. I hope you can get that. Well, this one's not complete. This one was a draft, but it's up there now. It is complete. It has all the information you need. Okay, the screws that I use to hold that down, I want to make that clear. These are a number 2, 3/16 long, round head, they call it, self-tapping. So they can kind of tap into the plastic if there's a hole. Now, in this one in particular, this is one I built earlier, and I got it off a little bit, so these little holes didn't line up from the top and the bottom. So sometimes you'd take a pin vise. If you don't have one of these or a set of these, they're not expensive, they're invaluable. You get a small set of bits, you can clamp them in here, and just by hand, you drill a plastic hole that you need. So you can stop, you can check how deep are you, It's a very handy tool. The other thing that I've had to use once in a while is thread tapper, especially on these inserts that are pressed into the plastic. These guys sometimes will get a little plastic behind the threaded insert, and you could get, you just don't seem to have enough thread in there. And what I do to clean them out is I'll put this in a pin vise, and I'll just go in and tap it out a little bit. And if I feel some resistance, I just go a little bit and back it out, back it out, a little bit, back it out. And then you check it and you'll see, maybe you'll get a little red plastic. You put it in there, you put your bolt, your screw in, and you test. Make sure it goes flush, hand tight, flush to the insert. Then you're good. You can do the same with the axles, and I've had to do that on these as well, where I may get some plastic in behind that. I want to make sure I can go flush with the wheel. This one's not quite flush, so I might need to drill that out a little bit and see what's in there. I don't know if there's something in there or not. It could be just a little bit of something in the way, you just don't know. And you clean it out a little bit, and you try it again. Oh, look, it's flush. Yeah, not exactly, but it's a little better. You check this one, you check this one may be out. I haven't checked this distance, so this may be more than 3 millimeters. That may be the case. No, 2.6. It should be 3.17. It's just a little out. But check your tips for 3. Make sure you've got the clearance so the wheel can go flush to this outside. You want the rib of the wheel to be rubbing on that brass outside piece, that minimum resistance that way, rather than the axle, if it's possible. That always works best. Okay, let me check my cheat sheet over here. I've checked everything out. The circle, the opening, the cut length versus the formed length, the difference in how you determine the length. If you make a custom side frame, for example, say you want one, a certain style, and nobody has it, but you can have the skill to design and print. You can design and print your own side frame as long as you know that the mounting hole has to be a certain distance, and then where you put the holes for the wheel, like we did in this one, we raised it and lowered it depending on what we needed in the way of clearance. So there's a lot of customizing that you can do when you're doing your own design. But I always encourage people to learn to design. It's very cool. It's a lot of fun. You can spend a lot of time designing. But anything else that I missed? Any questions? Write them down. Let me know. I hope this was visible for you all. I hope it was. Sorry about this thing. I'll make a new chart and post it somehow so you'll get it. It's all right here too. And I'll make it. I'll put it in. I'll put it in as a diagram in Thingiverse. So if you're cutting the wire, I'll say electrical or wire pickup instructions or something like that. That's what I'll do. Okay, that's it for the day. Now I'm going to go back and do some real work. Okay, later.